So in this session, I am going to explain S-metric representation for Model 2 of Microwaves and Antenna subject. It covers the course outcomes CO2. And in this session, I am going to explain the comparison between S, Z and the Y matrices and also the relationship of Z, Y and ABCD parameters with the S parameters and some question arrays. First, I am going to discuss about this comparison between S parameter, Z parameter and the Y parameter matrices. As we know that the impedance or admittance matrix for an N-port network represent all the circuit characteristics of the device at any given frequency, like the impedance or admittance matrix for an N-port network, the S matrix also provides a complete description of the network as seen at its N-port, while the Z parameter and the Y parameter matrices relate the total voltages and the current at the ports, and the S matrix relates the voltage waves incident on the ports to those reflected from the ports. So consider the scattering matrix S is related to the impedance matrix Z by the S matrix, that is a scattering matrix S equal to Z matrix minus unitary matrix into inverse of Z matrix plus of unitary matrix. Call this as equation 1. In similar way, the relationship between S matrix and the admittance Y matrix can also be expressed as the S matrix is equal to unitary matrix minus of admittance matrix. It is multiplied with the inverse of unitary matrix plus of admittance matrix, called as equation number 2. Then some of the characteristics for this that are: one is the number of elements in all these matrices are same. Second one, for the reciprocal networks, all the three matrices S matrices, Z matrix and the admittance matrix Y are symmetric matrices. That is Sij is equal to Sji for S matrix S parameters and Zij and Zji for Z parameters and Yij equal to Yji for the admittance parameters. So some of the advantages of scattering matrix S over Z and Y are: first one, using the microwave measurement techniques and frequencies, VSWR, power and the phase of microwave signals can be easily measured. The measurement of VSWR is nothing but the measurement of B by A. The power is measurement of mod of A square and measurement of phase is measurement of mod of B square. Such a direct one-to-one relationship does not exist with the Z parameter and the Y parameters. In second one, the power relations of lossless microwave structures and devices can be readily checked by using the unitary property of S matrix. Such a quick check is not available with the Z parameter and the Y parameters. Then third one, in the case of Z and Y matrices, the voltage and currents are functions of complex impedances and the admittances respectively. When the reference planes are changed, there is change in both magnitude and phase of the impedances and the admittances. But in the case of S matrix, the change in reference plane changes only the phase of the scattering parameters. These are some characteristics of S parameters, Z parameters and the Y parameters comparisons. Then the relations of Z, Y and the ABCD parameters with the S parameters. First, I am going to consider the Z parameters equations and the ABCD parameters equations. So Z parameters equations are V1 is equal to Z11 I1 plus Z12 I2. Call this as equation number 3. And V2 equal to Z21 I1 plus Z22 I2. Call this as equation number 4. Then coming to the ABCD parameters, V1 is equal to A V2 minus B I2. That is called it as equation number 5. Then I1 is equal to C V2 minus D I2. Call it as equation number 6. Rearranging the equation 4, we get that is I1 is equal to I1 divided by Z21 V2 minus of Z22 divided by Z21 I2. Then comparing equation, that is equation number 7. Then comparing equation 6 and 7, we get C is equal to 1 by Z21 and D is equal to Z22 divided by Z21. Then substituting I1 from equation 7 in equation 3, we get V1 is equal to Z11 multiply with V2 divided by Z21 minus Z22 I2 divided by Z21 plus of ZI2 into I2. Then V1 is equal to Z11 V2 divided by Z21 minus in the square bracket, that is Z11 Z22 divided by Z21 minus of Z12, that all multiply with I2. That is called as equation number 8. Then comparing equation 5 and 8, we get A is equal to Z1 divided by Z21, called as equation number 9, and B is equal to Z21 Z22 Z11 Z22 divided by Z21 minus of Z12, that is called as equation number 10, and C is equal to 1 divided by Z21, called as equation number 11. D is equal to Z22 divided by Z21, called as equation number 12. Then similarly from the set of equations of considering the y parameters, that is I1 is equal to y11 v1 plus y12 v2, call this as equation number 13, and I2 is equal to y21 v1 plus y22 v2, call this as equation number 14. From the equation number 14, we can write it as v1 is equal to minus of y22 divided by y21 v2 plus 1 divided by y21 into I2. That is called as equation number 15. Then comparing equation 5 with equation number 15, we come to know that A is equal to minus y22 divided by y21 and B is equal to minus 1 divided by y21. Then substituting for v1 from equation 15 into equation 13, we get I1 is equal to y11 into bracket minus y22 divided by y21 v2 plus 1 divided by y21 into I2 plus of y12 into v2, and similarly I1 equal to, that is into bracket y12 minus y11 y22 divided by y21, it is multiplied with v2 plus y11 divided by y21 into I2. So this total equation, it is represented equation number 16. Then comparing equation 6 with equation number 16, we come to know that C is equal to y12 minus y11 y22 divided by y21, call it as equation number 17, and D is equal to minus y1 divided by y11 divided by y21, call this as equation number 18, and A is equal to minus y22 divided by y21, call this as equation number 19, and B is equal to minus 1 divided by y21, call this as equation number 20. Then when the characteristic impedance of input and output lines at the junction are same, then the S parameters in terms of ABCD parameters are found to be S11 equal to A minus B minus C plus D divided by A minus B plus C minus D, call this as equation number 21, and S22 is equal to minus A minus B minus C minus D divided by A minus B plus C minus D, call this as equation number 22, and S12 is equal to minus 2 into AD plus BC divided by A minus B plus C minus D, call that is equation number 23, and S21 is equal to 2 divided by A minus B plus C minus D, call this as equation number 24. Then substituting the set of equations 9, 10, 11, 12 in equations of 21, 22, 23, 24, we get S parameters in terms of Z parameters. Then similarly substituting set of equations 17, 18, 19, 20 in equation 21, 22, 23, 24, we get S parameters in terms of Y parameters. So some of the questions for this session is write the comparison between the S, Z and Y matrices and explain the relationship of Z, Y and the ABCD parameters with S parameters. Some of the multiple choice questions are: first one, ABCD matrix of the cascade connection of two networks is equal to the product of ABCD matrices representing the individual two ports. And for a simple impedance Z, the ABCD parameters are A is equal to 1, Z is equal to B, C is equal to 0 and D is equal to 1. Then another third one, that is ABCD matrix is used when there is a two or more port networks in the cascade. If the reflection coefficient of a two port network is 0.25, then the return network loss in the network is 10 dB. Then session conclusion. In this session we conclude that we come to know the comparison between S, Z and Y matrices, and also we come to know that the relationship between the relationship of Z, Y and the ABCD parameters with the S parameters. Thank you.